Okay, question 5. We're starting with this equation, and we've got to do some easy stuff first. We've got to find dy by dx, so we just have to differentiate it. So e to the x differentiates to itself, and you've got a rule for differentiating e to the kx. So after differentiating this, you're going to have similar kinds of terms in the answer. 12x is a core 1 differentiation that you should have no problem with. And then you need to find d2y by dx squared by differentiating your previous answer. Make sure that you write dy by dx equals, and you write d2y by dx squared equals, because you've now got 3 expressions which in some respects look similar to each other, and you need to make sure you use the correct one at each stage in part B of the question. Because when we get to part B, we've got stationary points. Now stationary points, you know from core 1 and core 2, the stationary points is code for the gradient equaling naught. So you need to pick which of these 3 things is giving you the gradient and equate that one to naught, but not one of the others. So that's why you have to be very careful about knowing which is which. Okay, so we are doing a show that, and therefore this is the end point. So we're going to arrive at this equation. We're going to start with one of these things equaling naught, and there'll probably be a little bit of easy simplification we have to do to get to this end point, and you have to do that convincingly for your 1 mark. Then it says use the substitution z equals e to the x, because right way back here you may have spotted that with e to the 2x here and e to the x here, if we call this one here z, then this thing here is going to be z squared. Okay, I've given it away. So this isn't very nice because of the 12x, but this one here, which is comes from after some differentiation has happened. Okay, this one here, we've got some z's here. This is what we just said. So this is a quadratic equation. So you write down your quadratic equation in z. So you're going to have some number of z squared plus some number of z's plus some number equals naught. You're going to solve it by factorizing. You're going to get 2 values for z's. And then you're therefore going to remember that z is e to the x, so you've got e to the x equals first thing, or e to the x equals second thing, and we just need to find the x values, and it tells us the answers. Notice they are given an exact form as lns, which is what you would normally do. If they didn't give you the form of the answers, that's what you're expecting to do, to give exact answers in this kind of question. Okay, so we've got the x coordinates of p and q, because that's what the equation was for. Okay, so this equation was all about the x-coordinates of the stationary points. Now we need the y-coordinates. How do I find y-coordinates? Well, if only I had an equation that told me what y is. Well, I've actually got 3 equations here, and if you've labelled them correctly, you remember which one is y. So it's this one, it's not that one, it's not that one. Okay, so the y-coordinates are p and q. Here are the x-coordinates, so I'm going to shove them into the equation to find the y-coordinates, and I'm not going to cheat, and I'm going to give my answer in this form. So because of the form of this answer, your calculator's no use to you. You have to put values into here that are logs, and the one that's slightly more interesting is when you have to do something like e, come over here, you have to do e to the power of something like 2 log 2. If it was e to the power of log 2, then that just turns into the number. In fact, that's how you got log 2 in the first place. E to the x had to equal 2, I think, for that one. So e to the power of log 2, and your calculator will help you. E to the power of 2 log 2, well, as a last resort, you could use your calculator for this. If you do that by itself, then your calculator will tell you the answer. But in order to get your method marks, they are looking for some kind of method here. So what you need to do with this 2 log 2 is to write it as log of something. So you have a law of logs for n log of x. If I can write it properly. N log of x, you happen to know, is log of something. So consult your laws of logs, and so if you've got 2 log of 2, then that will turn into log of something involving the 2's here, which if you do it convincingly will enable you to simplify without any use of calculator, simplify this y expression after you substitute in these 2 x's. Okay, and it shows you what the answer should look like. Then, using that answer, so this is a re-entry point, using the answer to a dotted 2, determine the nature of each stationary point. Okay, so the nature of the stationary points, that means is it a maximum or is it a minimum? Well, remember there were 3 things we started with, y, dy by dx and d2y by dx squared. By this point in the question, you've already used 2 of them. It's the other one that you haven't used yet that tells you whether you've got a maximum, or can tell you whether you've got a maximum or a minimum. So you're going to be shoving these x values into something else and commenting this time on whether the answers are positive or negative, and then linking that very clearly to whether you're saying the stationary point is a maximum or minimum. So I hope that helps.